Today we have a rather complex math problem. We are given that the cube root of 4 minus x squared plus the square root of x squared minus 3 is 1, and we need to find out what x is. The first thing we need to do is use substitution to figure this out. So let's just substitute something. Let's let a be equal to the square root of x squared minus 3. So therefore, a squared is equal to x squared minus 3. Now we need to make this in terms of a, so we can also do that, like break it up. So 4 minus x squared, this is just equal to 4 is 1 plus 3 minus x squared, right there. So we can rewrite it as 1 minus x squared minus 3, because we take out the negative 1. And now we see that this is a squared, so we now know that 4 minus x squared is equal to 1 minus a. Right there. No, sorry, 1 minus a squared. Sorry. Now we plug these values of a squared and 1 minus a squared into the original equation. So we now have the cube root of 1 minus a squared plus the square root of a squared, which is just a, is equal to 1. Now we move the 1 to the left-hand side. So 1 minus a squared, cube rooted 3 times, plus a minus 1 equals 0. Now our next step is to try and make this a 1 minus a squared. We can actually do that. So 1 minus a squared, cube root 3 times. This is going to be just minus 1 minus a is 0. Yeah. And now we can actually rewrite this in terms of a cube root. So the cube root of 1 minus a squared minus 1 minus a. In order to make it a cube root, you have to cube it and then cube root it is equal to 0. So now we have turned the original equation that we are given into a completely new one. Alright, so now that we figured this out, we can actually solve for a. We see that on the left-hand side, 1 minus a squared, that looks like equation a plus b times a minus b. 1 is just 1 squared, so we can rewrite the left-hand side as 1 minus a times 1 plus a, and you cube root it, and then you just subtract 1 minus a cubed, take the cube root of it, equals 0. Notice the value didn't change at all, because we just turned this into an equation. Now we see that both of these terms have a factor of the square root, the cube root of 1 minus a. So we can take that out. So it's going to be 1 minus a cube root times 1 plus a, and take the cube root of that, minus the cube root of 1 minus a squared is 0. Now we actually have found out a. So our first answer for a, or first scenario in this case, is where 1 minus the square root, the cube root of 1 minus 9 is 0. So a is going to be 1 in this scenario. And the second one is where the cube root of 1 plus a minus the cube root of 1 minus a squared is equal to 0. Now, we just need to solve for this. To do that, we have to get rid of the cube root. So we write it on both sides of the equation. So 1 plus a, take the cube root of that, is equal to 1 minus a squared, and take the cube root of that. So we move this to the right-hand side. Now we get rid of the cube root. So 1 plus a is equal to 1 minus a squared. Or, according to the equation, 1, since 1 squared is still 1, well, I'll just write 1 squared, minus 2a plus a squared. So this, we can just solve it. So there's both 1, so those cancel. 3a is equal to a squared. So now we can rewrite this. 3a minus a squared is 0. So we can factor out an a. So factor out the a. 3 minus a is 0. Now we have two answers in this scenario, where the first one is where a is equal to 0, and the second one is where a is equal to 3. So we now have our three answers of a: 0, 3, and 1. Now that we figured out the three values of a, we can leak out an equation for x and plug them in. So from this equation, we get that x is equal to the positive or negative square root of a squared minus 3, plus 3, sorry about that. And from this, we can solve. So when a is equal to 1, x is going to be equal to... So when a is equal to 1, x is going to be the positive or negative 2. When a is equal to 0, x is going to be equal to positive or negative the square root of 3. And when a is equal to 3, x is going to be positive or negative 2 times the square root of 3. So we don't have 3 answers, we have 6 answers.